What are steel castings? When we talk about steel castings as a technology, as a product form, what are we talking about? What makes a casting a steel casting? What makes steel a casting? So that's what we're going to talk about this morning. Steel manufacturing, melting steel, was beyond the resources of most people in ancient times. Steel melts around 1600 degrees centigrade, around 2900 degrees Fahrenheit. And because of that, ordinary combustion sources, wood fires, charcoal fires, can only get to about 2/3 of that temperature. You can only get to about 1800 degrees Fahrenheit, 1000 degrees centigrade with a wood fire. Now, the Iron Age begins when you discover how to melt iron. And the way you melt iron is in a tube. It used to be a stone furnace, and you mix in the tube. You start a fire in the bottom, and then you mix charcoal with iron ore and scrap iron and limestone, and you melt the steel with that fire. This is a small cupola, and basically when you're melting the steel that way, you're allowing the carbon in the charcoal to react with the iron oxide and the ore and form carbon monoxide, and that creates a lot of heat, and it also allows the carbon, some of the carbon, to go into the iron, and that high carbon iron has a lower melting temperature, and the reaction of the oxygen with the carbon raises the temperature so that you can actually make cast iron. So these are molds, and when we cast, we pour liquid metal into molds. These are molds made by students who scratched some image in it, and they're used to make plaques. And you can see in this video, they're actually tapping. There's where the air goes into the furnace. They're tapping cast iron into a small ladle, and when they pour that small ladle into these molds, then when that cast iron freezes, it has the shape, so each kid that made a mold will get his little plaque with the image that he scratched in the mold. The beauty of the casting process is the liquid metal can take any shape that you create in the mold. So that's the casting process. The challenge is in steel making, we couldn't melt iron conveniently in ancient times. The Japanese learned how to make steel in a coffin-like furnace, but they couldn't make shapes because they couldn't melt it and pour it. And so there are no steel castings before modern times. Cast iron, on the other hand, goes back 2,000-3,000 years. And in fact, I was just in Pennsylvania at the Mount Vernon furnace, which was operating during the Revolutionary War. It was a stone furnace that basically operated just like the small cupola you saw. Because when you use charcoal or coke to melt iron and iron ore, what you end up with is the iron or steel absorbs the graphite. So you have about 3.5% carbon that gets absorbed. And when it solidifies, that graphite forms a continuous network of these flakes. So when you break a cast iron skillet or break a piece of cast iron and you look at it, the fracture surface doesn't look bright like metal. It looks gray, which is where gray iron got its name, is in the fracture. When you look at it, it looks gray instead of shining. This traditional material was used extensively throughout the world to make cooking pots and all kinds of things, but it didn't have any ductility. You can see that an ordinary class 40 gray iron has only about 30 KSI yield strength. Elongation of 0.5% is optimistic. When I've measured it in the past, it's more like 0.1% or even less. It just breaks. It doesn't stretch. The toughness, hitting it with a hammer will shatter it because the toughness is 1/5 the toughness of a steel. And of course, you can't weld it because the high carbon would cause the welding to crack. But it can make beautiful objects. So if you want to cast a material, gray cast iron casts beautifully. And so you can make pots and pans, you can make other miscellaneous hardware. If you wanted something that was stronger, you actually had to go on a forge and melt and burn out the carbon, but you never melted the iron. You just burned out the carbon and made wrought iron, which had no carbon at all. Then in the mid-1700s, they discovered how to melt steel. And the way you melted steel was you took cast iron and melted it, because you could barely melt it with a really preheated furnace. And then you would drop in iron oxide. So you would reverse the reaction that you used to make the cast iron, where you took iron oxide and reduced it with carbon. And here you'd actually take high carbon cast iron and reduce the carbon with iron oxide, and you'd actually create steel by using iron oxide or ore to take the carbon out. And if you take the carbon out, typically instead of 3.5% carbon, a steel only contains about 0.2% carbon. And so ASTM, WCB, the most common steel alloy, you can see the yield strength is 25, 30% higher, but you stretch, this is the specification minimum, you stretch 30 or 40% before you break, and you have 10 times the toughness, and this welds as easily as any other kind of steel. This micrograph is the same size, and you can see these little black specks. These little black specks are not graphite. They are mixtures of steel and carbide, and they strengthen the alloy. So that's what makes it stronger. And so this material is just like the material you'd buy if you bought steel from a steel supplier, except it's cast instead of rolled. So, to be honest, all steel is cast. All steel made today is melted, so it's liquid steel, and then it's poured into a mold. Most of the steel is melted from scrap in an electric arc furnace. Because of mini mills, we don't make much steel from iron ore anymore. Most of it's remelted scrap. In rolled products, we cast either a square bar in continuous casting, or we may cast a big ingot, and then we heat it and roll it into the plate or bar or pipe or whatever you want. In steel casting technology, we actually cast the steel into the final shape. So this video is actually steel from the World Trade Center that was melted down in a meat foundry, Bradken meat, and used to pour the bow stem. So this is a mold that has the shape of the bow stem, and this is steel that came from the World Trade Center that was remelted, and this foundry is casting the bow stem for the USS New York. So in steel castings, we actually pour liquid metal into a mold. So this is the shape of the part we want. And you can see the liquid allows us to make complex internal shapes, complex external shapes directly from the liquid material. This is the gating or plumbing system to let the metal in. And these tall cylinders are the risers to make sure that the casting is sound. So why would you use a steel casting? Because you want geometry. If all you want is a plate or a bar, you don't make it as a casting, you roll it. But if you want something with complex internal shapes or external shapes, you probably want a casting. Castings are really capable of very difficult environments. One of the biggest markets is railroads. We make the couplers. A large train may have 14,000 tons, 12,000 horsepower, and it's held together by the castings that make up the couplers. And so steel castings are capable of operating at extreme temperatures and extreme stresses and high toughness and safe environments. We're used in critical components to transmit power, connect structures, and consolidate parts. You can make all kinds of parts as a single part as a casting. We can also make really complex internal geometries, or we can provide materials that you can't machine or forge. And so we can make materials and components that are unavailable with other technology. We use solidification modeling to do the engineering to make sure that the castings are sound and have the material properties you want. And so this is solidification modeling showing that the last solidification happens in the risers where it shrinks, and we cut those off so that you end up with a sound casting. We also have special processes, like this is showing centrifugal, this is a vertical, this is a horizontal centrifugal casting where we have a spinning mold and we put steel in it. We can also use ceramic molds and make investment castings, and those are all used to make different quality, different shapes, and different kinds of castings. One of the challenges we face is because people have the experience with cast iron breaking, being brittle, many people think that any cast material is brittle. But the steel that we cast is the same kind of steel that they roll into bars and plates. And because we make to the same kinds of specification, ASTM specifications, we test every heat. So we do tensile tests, we do welder qualification, we even do toughness testing. And so the steel that we make is just as much steel as any other product. And so the beauty of steel castings, what steel castings are castings that have the complex geometries that you can make any design you can imagine. We can even print the molds using 3D printing so that you can make any geometry you can imagine. And when we get done, it's not made out of some brittle cast iron. It's made out of real steel with the properties you'd expect. So thank you, and we'll invite any questions to Steel Founder Society. You can always send us questions at our website, and we're happy to answer any questions you have about steel and steel castings.